So the last example that we looked at, or the last two examples that we looked at, we were able to determine the empirical formula based on mass composition data, all right? Now, of course, and we learned this earlier, I think we covered this in chapter 2, there is a difference between the empirical formula for a compound and the molecular formula, right? So just to remind you of what a molecular formula is, the molecular formula basically gives you the number of atoms of each element present per molecule of the compound, while the empirical formula gives you the simplest ratio of the atoms of the different elements present in the compound. And of course, there's a relationship between the empirical formula and the molecular formula. As stated here in this first line, basically the molecular formula is a simple integer multiple of the empirical formula, all right? In other words, in order to get from the empirical formula to the molecular formula, we have to multiply the empirical formula by an integer. So when it comes to doing that transformation, the question now becomes, how do we determine the integer by which we multiply the empirical formula to get the molecular formula? And the answer is right here. Basically, if you know the molecular formula mass and you know the empirical formula mass, which of course you obtain by adding up the atomic masses of the elements according to the empirical formula, if you divide the molecular formula mass by the empirical formula mass, that will give you the integral factor. That's an integer. And that integer is what you're going to use to multiply the subscript of the different elements in the empirical formula to get the molecular formula. All right? So that's basically how you go from the empirical formula to the molecular formula. You have to find the integral factor and then multiply each of the subscripts in the empirical formula by the integral factor, and the result would be the molecular formula. So a simple example is shown here. And in this example, let me just turn on my pen function here. In this example, they gave you the, oops, sorry. Okay, why is this? Okay, for some reason, it's not. Okay, I don't know what's going on with my pen function here. Okay, you know what? Let me get out of this here and go to this here. Maybe this will behave itself. Okay, so basically in this question, in fact, let me go back to the PowerPoint and let me read the question. So they gave you the empirical formula, right? C3H3O, and they gave you the molecular mass, 110 AMU, and the question is asking for its molecular formula, all right? So let me go to my writing application here. So basically, what we need to do is, firstly, I'm going to establish, what is going on? Oh my goodness. Okay, so the empirical formula is C3H3O, all right? And the question is asking for the molecular formula. So what we need to do is find, firstly, the integral factor. And the integral factor, as we said before, is equal to the molecular mass divided by the empirical formula mass, all right? So the molecular mass, of course, is given as 110 AMU. And the empirical mass is based on the empirical formula here. So the empirical mass, we can calculate it here. That will be 3 times 12.01 AMU plus 3 times 1.008 AMU plus 16.00 AMU. So 12.01 times 3 plus 3 times 1.008 plus 16. Okay, so according to this, according to my calculation, this works out to be 55 point, how many sig figs? 55.05 AMU. And that number goes here. So you're going to get 55.05 AMU. So let me do the calculation. 110 divided by 55.05. And according to my calculations, this works out to be equal to, okay, in this case, I'd round off to 2 sig figs. So that would be 2.0. But this has to be an integer, so this would be equal to 2. All right? So therefore, the molecular formula would be equal to C3H3O multiplied by 2, which would be C6H6O2. And that would be the molecular formula. So that's basically how we get from the empirical formula, which is this right here, to the molecular formula. These are the steps we have to go through in order to carry out that conversion. Okay,